Desiree, welcome. You're in space now.
Even when I'm not in space, my mind is still in space.
Oh, so as myspace.com. What is this? Hold on a second, you guys. Okay. So as you probably, Daniel, what the heck is myspace.com? Is that back? You made it, making a comeback? Anyway, as you saw, I graded your exams. Oh, guys. And your overall grades are on Canvas. As a class, you guys are doing really well. If your overall percentage is less than 60%, you might want to talk to me. There's not many of you, but if you do have an overall percentage less than 60%, it's I don't know how to say this nicely. It's mathematically impossible for you to get a passing grade in the class, because even if you were to get 100, I think out of all your teachers, you would at least believe me on the math, right? Okay. Even if you were to get 100 on the final, it wouldn't pull your overall average to a 70. Having said that, I always get questions, well, what if I get 100? Or, I mean, like, come on, you haven't been able to get over a 75 on a single exam. How are you going to get 100 on the final? Anyway, there's not that many people. Most of you are doing well. If there is a situation, now keep in mind, I do want to talk to you if you have less than a 60%, and I'll discuss this with you. Hold on, let me see something real quick. 1 second. So the drop deadline as was extended this semester. I think it's this Friday or Saturday. Our dean just sent an email. Let me check the email. I'll tell you, read it exactly. Where did it go here? I know that there are strong feelings on both sides of the issue of extending the drop deadline and allowing students to get an EW with no dog. However, okay, so Sunday, May 16th. So actually some professors don't like it, but anyway, it's been approved by the school. So just keep that as a reminder for your other classes if most of you are doing well. Okay. So the answer key is posted on Canvas. So you can take a look at it. So and hopefully you guys all had a chance to okay, this is really getting weird whenever I want to. Okay, give me a second. Okay, there we go. So hopefully you guys all had a chance to look at the 5.5 lecture. I told you to make sure you look at it, attempt the homework before class. Are there any questions for 5.5? No. Okay. Did you guys look at the video? Number 9. Okay. All right. So that's a good one. So if you integrate 1 minus 2x to the 9th power dx. So looking at this, I would say, all right, well, again, column formula A, B, and C, that's just easy to refer to it. It looks like a formula, power formula, something to the 9th power. So I'm going to say, all right, suppose I let my u equal 1 minus 2x. So I have u to the 9th. So what would my du have to be? Well, the derivative of 1 minus 2x is negative 2. So remember, du is always whatever the derivative is times dx. Now let's go back to the original u. Do I have a negative 2 dx sitting outside? No, I just have a dx. If it's just by constant, we're okay. We'll just solve for dx here. Divide both sides by negative 2. So I get 1 dx, or just dx equals negative du over 2. So now we're going to write this in terms of u's. So you have u to the 9th, but instead of the dx, you're going to write dx is equal to, which is negative du over 2. So I'm going to factor out the negative 1/2. Now, what's the derivative of u to the 9th? It's u to the 10th, divide by 10, plus c. Now replace what u is. So this is negative 1 over 20 times u is where did you 1 minus 2x. Aman, welcome to class. No video today? Welcome. Any questions? Let's go to let me another one here for you guys. This is an even one, but I figured it's a good one. Before I do it though, let's do this one. Let's go back to what we do derivative. How we take derivative of the inverse tangent function. Anyone remember? It's 1 over 1 plus x squared, right? Sorry if someone was typing in that. Under 1. So let's do problem number 32 from section 5. Let's integrate x over x squared plus 4 dx. Oh, hold on, that's an easy one. Well, let's do that one. So in this case, it looks like a du over u. I call it formula C in the lecture, but it's du over u. Don't say formula C to your next professor. So looks like that bottom right here. If that's my u, x squared plus 4 du would be 2x, and that's pretty darn close to where I love it. So what you would do here is you would say u equals x squared plus 4. du equals 2x dx. Do I have 2x dx right above it? Close. I have x dx. So I have to divide both sides by 2. Why do I divide by 2? Because I want the x I want to match what I have up here. So now we're going to rewrite this as in terms of u's. So this is u on the bottom, and x dx gets replaced with du over 2. Now, for those of you that watched this video, you're probably lost here. I told you to watch it. I even gave you a reminder yesterday evening. Now, what's 1/2 times the integral of du over u? That's a very famous one. You're going to run into it all the time. It's 1/2 times the natural log of u. Remember that from the lecture? Okay. So then replace what u is, which is, well, right here, x squared plus 4. Now, technically, I don't need the absolute value here because x squared plus 4 is always positive. It's something squared. But so you don't have, you can drop the absolute value in just parentheses. All right. So that's that. Any questions on that? So Brian is asking, would it be okay if we went over from 15 from 5.4? Yeah, 1 second. Oh yeah, that's a messy one. Yeah, don't worry about that one. I'll do it. It took me a while when I originally did it. I put a little note next to it on how to do it to help me out because I might forget. I'll do it for you later, but let's say in this section. But yeah, number 15 would be a tough one. Aliyah, did you figure out how to do number 15 on 5.4? All right, let's do. I'll get to it. Just give me a reminder.
Wait, I have a quick question from the lecture. I might have missed it. How do you know what the limits are for u? I think it was like your...
You plug in the x value. So let's say you have x equals from 0 to 5. That's for u. If u equals 2x plus 1, well, you plug in 0, And if you plug in 0, you get u equals 2 times 0 plus 1. So u equals 1. So when x equals 0, u equals 1. If x equals 5, u equals 2 times 5 plus 1. So u equals 11.
Got it. Thanks.
All right, so I want to do this one. This next one is a pretty good one. Number 44 from the book. The integral of x over 1 plus x to the 4th dx. So Omar, I'm talking about number 15 from section 5.4, not 5.5. Did I assign number 15 on 5.4? So here's the thing. At first glance, when you're looking at this problem, you're thinking, well, maybe du over u again. But don't write this down. If you try to do du over u, and 1 plus x to the 4th, so therefore du would be 4x cubed dx, you're wondering, wait a minute, I can never get this to be 4x cubed dx. That's off by more than just a constant. So I got to go another route. So now, how do you know to go this route that I'm about to go? It comes with a lot of experience. That's why you just got to practice these. So x over 1 plus x squared squared, I noticed that the inverse tangent function is 1 over 1 plus x squared. That's why I did that for you right here real quick to give you a reminder. So, so what if, again, you would a lot of times play around with this. You might not get it on the first try. You would say, all right, let's say, what if u equals x squared? Then du would be 2x dx. Do I have 2x dx right above it? Close. I have x dx. So you would say, okay, how do I get this to be x dx? Well, divide both sides by 2. So du over 2 equals x dx. So if I were to rewrite this now in terms of u's, it would be 1 plus u squared downstairs. Then the x dx gets written as du over 2. So I can factor out the 1/2, and I get integral du over 1 plus u squared. And if that still doesn't look nice, you can always write it as 1/2 times the integral of 1 over 1 plus u squared du. Du or 1 times du is the same thing. So notice now, at this point, what is the antiderivative of 1 over 1 plus u squared du? That's the arctangent, right? Because the derivative of arctangent right here is 1 over 1 plus x squared. So therefore, the antiderivative of 1 over 1 plus u squared is 1/2 times the arctangent of u plus c. And then what is u? It's x squared. So 1/2 times the arctangent of x squared plus c. And that's our final answer. Now, this was quite a bit of work. Taking the derivative was much easier. So back several weeks ago, if I told you, take the derivative of this for me, you don't need to put the plus c when you're checking because the derivative of that is just 0. If you were taking the derivative of this a few weeks ago, what would you do? You would say, oh, it's arctangent of something. So the derivative is 1 over 1 plus x squared squared, chain rule, times the derivative of the inside function. What's the derivative of x squared? 2x. Oh, there's a 1/2 here. We're going to bring that down. So there's a 1/2 here as well. So the 2 and the 1 and 2 there cancel out. So you get 1 over 1 plus x to the 4th. Oh, x, I mean, there's an x there. 1x. So So this was much easier taking the derivative because you have the chain rule. Going backwards is a little bit more work. All right. So someone has asked me, yeah, so I missed the chat here. So I'm going to do number 15 from 5-4. Also, is our final next week Thursday? Yes, our final is next week Thursday, regular time. Do the other 5-5 first, please. Well, that's what I did. Okay. Okay. All right. I believe you, Omar, that she may have done it, but I wouldn't say it's not too bad. I'd say it's pretty bad. So I think we're talking about a different question. This is 5.4, number 15. So Omar, Dejani, did she do this one?
Yes.
Yeah, how did she do it?
Let's see. First she turned the 2 into a 1 plus 1, and then she turned the tangent squared to a secant squared.
Yes, but yes, that is correct. But how would you know to do that?
Yes, that's what I told her. That just seems so weird.
So why'd you say it wasn't too bad?
Well, I mean, never mind.
Yeah, I do mind. Okay. Yeah. So yeah, once you know that, then you remember your trig properties, which is a big if. 1 plus tangent squared is secant squared. Yes, if you know all that, then it's not too bad. So the antiderivative of 1 is theta. The antiderivative of secant squared is tangent, and then plus c.
Professor,
Yeah.
the way I think I messed around with the Pythagorean IDs, and I got tangent squared theta over 2 minus theta plus 2 theta plus c. How far off was that? Was that pretty far off?
Well, I didn't catch it again. Tell me what you wrote tangent as again.
I put tangent squared theta over 2 minus theta plus 2 theta plus c. I was kind of like, I flipped back and forth between the Pythagorean ID and then I think
I have to look at it. It's kind of tough. I don't think it's right, but if you want to send a picture of it, email it to me, and I'll tell you what you did wrong. Yeah, I have to see it in front of me. But I think this is the only way to do it. I actually want to see, I mean, you wrote tangent squared equals, yeah, I mean, this is the way I think, this is the way you're supposed to do it. All right. So practice 5-5, you definitely need to know how to do this. Now, here's what I want to do. I'm going to talk about 6.1 a little bit. I'm not going to put 6.1 on the final because it's not part of the class. You will cover it next semester. But I do want to go over some basic stuff here. Then I'll start reviewing. And I also posted a review sheet last night for you. It's not a comprehensive review sheet. It's just mainly the later stuff, but I did put some of the earlier stuff on there. We'll go over that on Thursday, along with any other questions you have. So Thursday will be a review day. As far as next week on Tuesday, I don't really have any plans. A virtual potluck. And then I can answer more questions. And then next week, Thursday, May 20th, is your final exam. I'll tell you on Thursday also what things to focus on when you're taking the test. So let me talk about 6.1. I do want to talk about this because I want to talk about it. Areas between curves. So just, I'm gonna give you a brief. So don't worry about taking notes on this. If you want to, you can screenshot it afterwards. Just pay attention. I want to, because some of it is not on the final, but some of it also, I make references to stuff you learned earlier this semester. So I want to kind of like explain a few things so you're kind of good to go next semester. Here's the thing. When I asked you, hey, you have some function f of x, and you want to find the area underneath the curve from A to B. So let's say this is A, this is B, and you want to find the area of this shaded region, okay? So what we've already done this semester is you say, all right, well, if you integrate from A to B of f of x dx, that gets you area of this orange region. Well, let me just get a little bit more theoretical for you. So what we did is we have a representative rectangle. So this blue rectangle, that's my representative rectangle. It's a very small rectangle. The width of it is delta x. Now, when you take the limit of the Riemann sum as delta x gets really thin, so thin that there's like millions of these rectangles all over here. But I'm not drawing them all. I'm just drawing one as a representative. So what's the area of that representative blue rectangle right here? This blue rectangle, what's the area of it? Well, the height of the rectangle is f of x. Well, width of it is, so the height of it is f of x. The width of it is delta x. But when you take the limit as n goes to infinity, that delta x becomes dx. And then you're going to add all of these millions of rectangles up from A to B. So you're taking the summation of them. The summation, hence a stretched out S, all the way from A to B. And that will give you, when you're adding up all these infinitely many rectangles here, that gives you the area underneath the curve. So that gives you the area of the orange region exactly. And then of course, you know how to evaluate this by just going taking the antiderivative, plugging into the top minus. So that's kind of where you can see where it comes from. F of x is the height, the dx is the width. Now, and then you add them all up from A to B. Let's take it a step further. What if you had two curves? Like let's say we had this curve, call it f of x, and then you had another curve, call it g of x. And I want to find the area of the region that's bounded by these two curves. So this orange region right here. How would you find this area? Well, first of all, you need to figure out where they intersect at. So the points of intersection would be this point and this point. And then that point, you care about the x value. So we'll call that x value A and that x value right here B. So again, you draw your representative rectangle. So my representative rectangle is going to be like right there. What's the formula for the area of that blue rectangle that I just drew? Well, if you look at the screen where, not the iPad, but me, if I want to get the area of that rectangle, if I take the area underneath f of x, it's this height, minus the area underneath the red, which is this height. If I go this minus this, that will give me the area left over, right? So let me just look on the iPad here. So right now, hold on. If I were to just integrate underneath f of x, that gives me the area of this whole orange region, right? So if you integrate from A to B of f of x, it gives you that area. But I want to take away this area. To get what's left over as orange. So wouldn't I integrate f of x minus g of x, and that will give me the orange region? So And so the height of this rectangle would be f of x minus g of x. That's the height. The width of the rectangle is delta x, which becomes dx. And then you integrate from a to b, and then that will give you the area of the orange region. So let's do an example. Suppose I asked you to find the area of the region bounded by the curves. By the way, the word curve is a general term. It could be a straight line. We still call it a curve. Y equals x squared minus 2x and y equals x plus 4. Now, it's really helpful that you know how to graph. So this is just a parabola. This is just straight line. If you have trouble graphing parabolas, graphing lines, graphing the sine function, the cosine function, I would recommend Khan Academy before you take Math 152 and just watch some videos. So when I teach business calculus, of course, I don't have time to teach all that. I mean, like if you don't know how to graph a parabola, I can't teach you all about it. But I would say, hey, at least y equals x squared minus 2x is a parabola that opens upward. And y equals x plus 4 is a line with a positive slope. So if they were to intersect, you could see that the y equals x plus 4 is the top graph. And then the y equals x squared minus 2x is the bottom graph. And we're finding the area of this region right here. Now, I'm not going to graph for you exactly because I'm going to show you that the problem can still be done. But I'll graph it for you exactly once I'm done with the problem. So keep in mind, just because you have a parabola and a line doesn't mean the graph is going to look like that. You could have a situation that looks like that, where they don't even intersect. Well, that wouldn't make sense. Then we don't have an area that's bounded. Or you could have a situation where the line intersects exactly at one point. That wouldn't make sense either because you don't get an area. So I'm assuming they intersect at 2 points like the first graph that I drew. So you have your representative rectangle. What's the height of this rectangle? It's the top graph, x plus 4 minus the... Well, actually, you know what? Before I even do that, I need to know the points of intersection. I was jumping the gun here. How do you figure out where these graphs intersect? Well, set them equal to each other. One is x squared minus 2x equal to x plus 4. We're going to go minus x and minus 4, minus x and minus 4. So we got x squared minus 3x minus 4 equals 0. Factor. Two numbers that multiply to negative 4. We're going to go with minus 4 plus 1. So x equals 4, x equals negative 1. So this is going to be where x is negative 1. And this is where x equals 4. So what's the height of that blue rectangle? It's x plus 4 minus x squared minus 2x. What's the width? Well, dx. And you're going to integrate from negative 1 to 4. So this is the setup right here. You shouldn't be boxing it. That's not the answer. That's the setup. The hardest part is getting the setup. Once you set it up, the integration is actually pretty easy. They don't really make you do U substitution. So I would recommend you simplify the integral first before you actually take the antiderivative. So I would go x plus 4 minus x squared minus a minus is plus 2x. Combine like terms. All right, so then you take the antiderivative. So it's negative 1/3 x cubed plus 3/2 x squared plus 4x from negative 1 to 4. Now, it's a lot of number crunching from here. So you got to plug in 4 to everything minus plug in negative 1. So minus plug in -1. So then when you do all that calculation, you can do it later yourself. You're going to end up getting 125/6 or 20.83 with a 3 repeater. So what that would mean is the area of this orange region right here is 125/6. I don't know how many of you were writing this down. If you are, let me know. I can scroll back up so you can take a screenshot of it. So it's a little bit more involved. There's different types of questions you got to do in this section, but you cover it as your first section in Math 152. But be familiar with graphing. So it makes the problem easier. Not only you'll need to know how to graph basic things like square root of x or sine of x plus 2, or negative cosine of x, which is like the cosine function flipped around. Is then you're going to go into volume sections where not only will you graph, but you got to rotate it around the x-axis, and then you get the volume of the object that it creates. So be prepared. All right, so I won't bother you with this too much more, since we want to focus on the problems that we've covered already. Can you scroll up? Yes. All right. So the beginning of the question was right here. Let me hold on. Okay, there you go. So let's go ahead and screenshot this. There you go. There, and then once you screenshot that, and this is the rest of it. Got it? All right, so Aaliyah, do you have anything you want to mention to the class?
Yes. So my session on Thursday has been moved to Friday because I will be celebrating Eid. So I'm not working on Thursday, and I have moved it to Friday from 2 to 3. I hope you guys received my email about that. And that's pretty much it. Thank you.
So we are done with as far as new material for the semester. I feel like I finished a little early, like I'm supposed to covering new material today. Aaliyah, did I forget anything?
No, I think we're good. That's pretty much it, right?
Yeah, yeah, because in my Cal State Fullerton class, I'm supposed to cover area between curves, so that's what I had today reserved for that. But since you guys don't cover it, I didn't really cover it. I just did a problem. Let's go with. Give me 1 second. Let me. I'm gonna. Yeah, by the way, I don't need to pull it up. Have you any of you been on Canvas? Looked at the review sheet that I posted. It's there though, right? Okay, so do that between now and Thursday. Also 5.5 if you haven't done so already. And things you want to focus on, definitely want to focus on for the final exam, besides the stuff on the review sheet. Well, some of this overlaps. I forgot the review sheet exactly. So you better know the limit definition of the derivative. Know how to take the derivative, any type. So let's see here. Power rule. Product rule. Quotient rule. Chain rule. Implicit differentiation. Logarithmic differentiation. Related rates. Optimization. Those are the two types of word problems that we did. Although I was really happy with you guys as a class did well on the optimization problem in the test. The other thing I want to mention is I'm going to be a little bit more picky on this test as far as your camera angles. So you got a week to figure it out. I want to see the desk area and your hand while you're taking the exam. So don't worry, I will let you know. So if it's not okay. So on the test, if I say, hey, you need to lower your camera or you need to do this, be ready for that. And let's see what else here. So this is a lot of the earlier stuff. Just make sure you study. So I'm not going to ask you delta epsilon stuff on the final. So I don't even think I put it on the first exam this semester. But remember, for every epsilon greater than 0, there exists a delta greater than 0 such that x minus a is less than delta, then absolute value of f of x minus L is less than epsilon. I didn't even put it on the first test. Anyway, I'm not going to put it on the final. So don't worry about that on the final exam. Oh yeah, so someone was asking me in my other class, so do we only get 1 page of notes? Okay, fine, you can have 2 pages of notes. Here's the thing, if you need more than 2 pages of notes, you're going to end up taking too long. I just don't want a whole notebook where you're flipping through the notebook and then you run out of time on the test and then you blame me for making the exam too long, but in reality, you didn't know what the heck you were doing. Because if you're busy flipping through the notebook during the test, you're wasting time. In theory, you're not supposed to have a notebook to look at. You're just supposed to be looking at the test. So, okay, 2 pages. That's really 4 because you got front and back. So, what did I put here? ST. Oh, study. Study the old exams. There will definitely be the use substitution. Section 5.5, there'll be a couple questions from that. Holy crap, thank you. What is it? What did I do? I don't really see the difference between 1 page versus 2 pages of notes. You just write smaller, you fit everything in 1 page. You better know section 5.5. Now, again, I'm not saying these are the only things you want to study. These are just the things that I think of. I like section 5.5, and when you do questions like section 5.5 on the test, I want you to write it out exactly like I'm writing it out. You got to tell me what U equals, how you got your du and dx, all that stuff. Write it out exactly how I did. Now, I wouldn't be so picky if it was an in-class final, but it's online. I want it written out like the way I do it. If you want to know how I write it again, watch it on the video. That's why it's recorded. You can keep watching it over and over again and have a glass of wine while you're watching it. That's what one of my other students is like, oh, I drink when I watch your video. Oh my God. How many problems? Let's see. Don't hold me to this. 16, 18, I don't know. Not double because you get 2 hours, but it takes a while. So I'm thinking 16-ish, but don't hold me to that number. And there'll be questions where I test the understanding of if you know what the heck is going on. Let's see here. Give me a second. Let me look at some more exams here. Oh yeah, so be able to take a limit. Don't forget your limits, right? Finding a limit graphically. Finding a limit algebraically. Your famous theorems. IVT, MVT, equation of a tangent line. Let's see, we got relative max min. Well, basically all of those types of questions that I asked in that worksheet that I posted. Relative max min over which intervals is increasing or decreasing. So question here on the chat, is it cumulative from the whole semester or from the midterm and on? No, the whole semester. Oh, inverse trig functions. It's really not that hard if you get to use a page of notes. You better know the derivative of all your inverse trig functions and the antiderivative of them. Exponentials. So I know you guys know the derivative of each of the x, but do you know the derivative of 5 to the x or 6 to the x? And backwards, the antiderivative. So the final review sheet, whatever is on there. All right, I'm probably forgetting something, but oh yeah, remind me on Thursday. Oh, we're not gonna be on Thursday. remind me next week on Tuesday if I forgot anything. Dang, I finished early. I don't know what else to talk about. Well, any questions about it? Let me do a couple questions here for you. Let's do a 5-minute question. Number 15. I forgot which math trick. Did I do the birthday one, Lauren, for math tricks?
I'm not sure which one the birthday one is.
I'm not either. All right, let's see here. All right, here we go. Well, before we do this problem, let's do a math trick. Pick your favorite number between 1 and 9. Don't tell me. Multiply it by 2. Then add 5. Then multiply it by 50. Desiree, I'll wait until you get your calculator. All right, everyone caught up? James? Looking good today? Very serious? Yes. Plus, you're going to do one of the two things. You're going to either add 1770 or you're going to add 1771, depending on if you've had your birthday this year or not. So if you have not had your birthday in the year 2021, I did this one already? Did I do this one already, Madison? Okay, well, some of you don't remember it because of the stuff you do. So let's do it again. So if you haven't had your birthday, you add 770, had your birthday, add 771, minus the 4-digit year you were born. Now you should be down to 3 digits. The first digit out of the 3-digit number you have left is the number you started out with, your favorite number. And then the next two is your age. So I did this one already for you. Okay. Did I do the one where I add 5-digit numbers up? I think so. Did I do the one where you pick a country? Oh, I picked that one. Okay. Well, let's just do this problem here. I had some better ones, but I forgot them. I'm sure they're all over the internet. So let's take the antiderivative of cosine to the third theta times sine theta. So I noticed that, hey, I have cosine to a power, so I'm going to let u equal cosine theta. And then the derivative of cosine is something close to sine, so I'm thinking formula A, something to the third power. So what's du? It's negative sine theta d theta. So I have negative sine theta d theta close. It's just off by a factor of -1. So what we'll do is we'll divide by -1. We'll divide by -1. So we get negative du. That's a -1 there. So we get negative du equals sine theta d theta. So rewriting this, we got u to the third, and then sine theta d theta is negative du. So factor out the negative sign. How do you take the antiderivative of u to the third? Well, it's just the power rule. 1/4 u to the fourth plus c. Replace u with what u is, which is cosine. And if you're ever not sure if you did it correctly, we'll take the derivative of that and see if you get back the original. And you do. All right, so when you're running into questions like this, you have to ask her. Let's do number 23 here. So that what I just did was number 15, by the way. Let's do number 23. So again, these problems are handpicked to work out the way you want. So when you see secant squared times tangent to the third, you have to ask yourself, what do I let u be? Should I let u be secant or should I let u be tangent? Well, derivative of secant is secant tangent. It would be kind of tough to pull off here. But the derivative of tangent is secant squared is exactly what we have there. So it would be much better to let u equal tangent. It wouldn't work out the other way, just trust me. So u equals tangent theta. Now you guys try to finish this. So someone is asking, wait, why is u tangent and not secant squared? Well, because u is tangent, because you got to look one step ahead. If u is tangent, then your du, derivative of tangent, is secant squared theta, which would work out nicely. But if I were to let u equal secant squared, well, du of that, what's the derivative of secant squared? Well, that's a whole problem in itself. It's a power function. You meant, let's say, what if u was secant? Then it would be, du would be secant theta, tangent theta. Technically, we do have an extra secant and a tangent, but then there's two more tangents that I don't know what to do with. So it's kind of be hard to go from where this wouldn't make sense very well. So you kind of got to say what makes the most sense. So tangent du is secant squared theta d theta. So this would be tangent, u is tangent theta, so u to the third. And then secant squared d theta, that would be du. Hold on, there's noise coming from outside. It's distracting me. 1 second. Okay, are you guys with me so far? Yeah. So now from here, you can take that. There was actually no adjustments necessary. Du was exactly what I needed. I didn't even have to divide or multiply it by anything. So it's just 1/4 u to the 4th plus c. Replace u with what u is, which is tangent. And if you're not sure, you go to your scratch paper, take the derivative of that, and you should get back what you started with. You know what? Let's do one where you got limits to take care of. I forgot which ones as I did as an example. I did 56. Let's do number 60. So what makes this different is you have your limits 0 and 1. So when you do a u substitution, not only you got to, when you write it in terms of u, you got to change the 0 and the 1, because that's from x going from 0 to x equals 1. So if you remember the formula ABC that I wrote, this looks like B. You got u equals negative x squared. So e to the u. Well, if u equals negative x squared, what would du have to be? Negative 2x dx. Do I have negative 2x dx on the outside? No, but it's close. It's x dx. It's off just by a constant. So we'll divide both sides by negative 2 here. Why? Because I want to know what x dx equals to, which is negative du over 2. So replacing this, you got e to the u, and then the x dx is going to be negative du over 2. Now, I still got to put the limits here. What number goes here and what number goes there? Well, when x equals 0, this is a kind of an easy one. If u equals negative x squared and x equals 0, then u equals negative 0 squared, which would be 0. So when x is 0, u equals 0. All right, well, what about when x equals 1? Negative 1 squared. Now, be careful. Negative 1 squared, that's the negatives outside. It's not negative 1 whole thing in parentheses squared. It's just negative 1 squared. So that would actually be negative 1. The negative is on the outside. So it's from 0 to -1. Now you're not, and then of course, let me show you a little trick here. This trick is not necessary, but so we still got to solve that. So they got the integral from 0 to -1, which is backwards, of e to the u times negative du over 2. So let's factor out this -1/2. So if you can just do the problem the way it is, take the antiderivative, plug in the top number. Now, some people insist on having their top number being larger than the bottom number. So if you flip this from -1 to 0, you just flip the sign on the outside as well and become +1/2. What's the point of doing that? There is no point. It doesn't make the problem any easier. Some other problems it might make easier. So just realize that this problem and this problem are the same thing. If you change the position of the limits from A to B to A, just flip the sign on the outside. But anyway, I'll just do the top one the way it is. There is no reason to put it back in terms of x's, because we're just going to plug it in. So what's that derivative of e to the u? It's e to the u from 0 to -1. So I'll leave this -1 factored out. Plug in -1 minus plug in 0. E to the -1 is 1 over e, minus e to the 0 is 1. You probably having fun. In the back of the book, put an alternative form of the answer. Whatever you do, do not take out your calculator and give a decimal approximation. Don't do that in a math class, unless the directions say so. You can do that in your physics class if you want. I don't really care what you do with your physics class. That's very major.
Yep.
All right, let me know when you want to come to the good side. Now I'm just joking. Physics is really good. Just good luck finding a good professor. And I was going to say, if you major in physics, all you need is like 3 more math classes than you already have to take, and you can get a minor in math. I don't know those schools. Well, you said you wanted to go to the East Coast, right?
No, I just want to go north, apply to Berkeley, or down south to UC San Diego.
Yeah, we're calling UC San Diego down south. Texas is down south. All right, go down south. All right.
You look at the map, it is down south. So.
Now you want to know something interesting? You know where Reno, Nevada? That is actually more west than Los Angeles. Look it up. Go to the map. Look. Pretty interesting. I'll tell you some other more interesting. So when you look at the map of the world, I just just facts here. When you look at the map of the world, you're looking at a rectangular map. But in reality, it's a globe. It's round. So when it gets stretched out like that, I'm getting to my point. That's not funny. So it's an exaggerated map because what's in the middle, like let's say Africa, is actually larger than the map shows, and whereas Russia is in reality smaller than what the map shows. So don't get me wrong. Russia is still the largest country, but it's not as big as the map shows. The square miles of Africa is actually more than the square miles of Russia. Anyway, I don't know what this is, but I thought it would be interesting. Sometimes I look at maps when I'm bored, okay? Hey, it's better than what some of you guys do when you're bored, okay? We won't mention that. Okay. I don't really have anything else to say. Aaliyah, help me out here.
I think we're good. We could call it a day.
Okay. Well, let me do one more. Now, some of these problems, there's some that are really tough. I won't put some of them on the final, but sometimes in the book, this was a number even one, so you probably didn't run to it. That's number 24. I'll do this one for you. This is a really tough one compared to the other ones because it's not your traditional route. So let's do this one. You're saying, okay, maybe it's, okay, I got to rewrite it as x times x plus 2 to the 1/2, like that. So let me just do this one, then we're going to finish, so we won't take a break. So, so you're saying, all right, let's do u equals x plus 2. If u equals x plus 2, then du would be 1 dx, but I don't have a 1 dx sitting outside. I have an x dx. It's off by more than a constant. What do I do? Well, it's not formula B. It's not formula C. There's really no other function here, a sine function or a logarithm. What else is there to do? So what the route you take on this, and it's really hard to explain why I'm doing what I'm about to do, it just comes from experience, is, well, I want to know what x is. So what I'm going to do is take the u equals x plus 2 and solve it for x. So x equals u minus 2. So then I look at my original problem up here. Do I know what x dx is? Well, I know what x is. Dx is just u. So let's rewrite this all in terms of u. What is x? U minus 2. What is x plus 2? Well, that's just u to the 1/2 power. So just FYI, u, oops, wrong way. U is just the x plus 2, which is that. Then we got dx, which is just du. So dx is right here, which is equal to du. So I wrote it all in terms of u that way. So then once you get that, well, what do I do from here? Well, it's to the first power, so I can just distribute this u to the 1/2 to each term. So we get u to the 3/2 minus 2u to the 1/2 du. Now it's just a subtraction, so I can just take the antiderivative of each part individually. So add 1 to the exponent 5/2, divide by 5/2, which is the same as multiplying by 2/5, minus, here add 1 to the exponent 3/2, divide by 3/2, which is the same as multiplying by 2/3. 2/3 times 2, that's 4/3. And then plus c. Well, we're not done yet. What is u? U equals x plus 2. That's what I have there. So you got 2/5 times x plus 2 to the 5/2 minus 4/3 times x plus 2 to the 3/2 plus c, and that is the final answer. So this is number 24 in the book, but there's only like one poem like that, and it just happened to be an even one. In an old edition, it used to be the odd one, and I'm like, what the heck is that? The first time I taught the class, I'm like, that problem is kind of weird. It's completely different than the rest. Anyway, I am pretty much done. So study 5.5, the review sheet, come up with any questions that you have from the old exams. I'll do them for you. Then I will talk more about the final on Thursday. Try not to skip out on Thursday's class. You guys are pretty good. Anyway, I hope you enjoyed this class. I know math is not the most fun subject for some of you, but I tried to make this class lighthearted and fun, and you guys were really good with keeping up with the material. It was a good bunch. Well, out of the bunch that's left. Well, good luck. I'll see you on Thursday.